All right, let's dive right in. Today, we're going to pull apart one of those big, chunky questions from the AQA GCSE Chemistry paper. We're looking at question 8, all 11 marks of it. But don't you worry, because we're going to use the ultimate cheat sheet, the official mark scheme. I'm going to show you exactly how to get inside an examiner's head and write those perfect answers that get you every single point. Let's get to it. So here's our game plan. We'll start by looking at the whole question, then we'll break it down piece by piece. We'll cover alloys, recycling, and then this really interesting process called phytomining, how it works, and also its downsides. By the end of this, you'll see exactly what skills the examiners are testing with a question like this. Okay, let's get a look at the beast itself, question 8. It's all about copper and alloys, but it's a classic AQA question because it mashes together a few different topics. You've got to read a table, think about sustainability, and remember a very specific scientific process. So let's jump into the first bit. First up, we're looking at alloys. Now, with this first section is all about your data skills. These are two quick, easy marks to snatch up, but only if you're paying really close attention to what the table is telling you. So this is what you'd see on the actual exam paper. It gives you a bit of context about solders, which you know are just mixtures of metals. And then it gives us this thing, Table 4. Honestly, everything you need for the first two questions is sitting right there on the page. Let's really focus in on this table. We've got our three solders, A, B, and C. We can see their melting points, and we can see what metals are inside them. Now, have a good look. Compare the ingredients in solder A to the ones in B and C. There's one really important difference. Can you spot it? And here we go, question 8.1. The command word is suggest, but the most important bit is the instruction use table 4. The examiner is literally telling you the answer isn't just in your brain, it's right there in the data. They want you to connect that difference between the solders to a health issue. And the perfect answer, straight from the mark scheme? It's all about the lead. That's the one metal solder A has that the others don't. And what's the health reason? Simple. Lead is toxic. Or you could say poisonous. Either word gets you the mark. Easy as that. On to 8.2. Now this one's a little more subtle. Take a look at solders B and C. They contain the exact same metals, tin, copper, and silver. Yet their melting points are different. How on earth is that possible? If the ingredients are the same, what else could possibly be different? And the answer is all about the recipe. The mark scheme is looking for this exact idea. The proportions of the metals are different. It's a key concept with alloys. You can have the same ingredients, but if you change the ratio, you change the properties. It's a beautifully simple point for another mark in the bag. Okay, we've nailed the data part. Now the question completely switches gears. We're moving away from the properties of alloys and into the much bigger, real-world topic of sustainability. Now check this out. It's a 3-mark question. That's a massive clue from the examiner. They're basically telling you, I need 3 separate good reasons from you. The question wants to know why recycling copper is more sustainable than digging it out of the ground. Time to pull from your wider chemistry knowledge. And what's great is that the mark scheme is pretty generous here. It gives you 4 possible answers, and you only need to come up with 3 of them. So you've got options. You could talk about conserving the finite copper ores, or how recycling uses way less energy. You could mention that it reduces landfill waste, or that it avoids all the environmental damage that comes from mining. Just pick any 3 of those, and you've got the full 3 marks. All right, time for the biggest single chunk of marks in this whole question. This is where you have to describe a full-blown process, phytomining. It's a super clever but kind of weird way of getting copper out of low-grade ores. And here's the question for a whopping 4 marks. It asks you to describe the process. Now, that command word is so important. It means they don't want a random list of facts. They want a story, a sequence of events. You have to lay out the steps in a clear, logical order. So let's just walk through the perfect 4-mark answer, just like the mark scheme wants it. Step 1. You grow specific plants on land that has copper compounds in it, and the plants absorb the copper through their roots. Step 2. You harvest those plants and burn them. This concentrates all that copper into the ash. Step 3. You take that ash and dissolve it in acid, which gives you a solution of a copper compound. And finally, step 4. You get the pure copper out of that solution, either by using electricity or through displacement. That sequence is money. And hey, here's a little pro tip for you. The mark scheme loves it when you're specific. So for that final displacement step, if you want to really show you know your stuff, you can say you add scrap iron to the solution. Why iron? Because iron is more reactive than copper, so it literally boots the copper out of the solution. Naming a specific metal like that is a top-tier move. So if phytomining is this clever, green-sounding process, why aren't we doing it everywhere? Well, that's exactly what the final 2-mark question is getting at. It's not enough to know how it works. You have to evaluate its real-world problems too. The mark scheme lists a few really good reasons, and you only need to give 2 of them. You could say it's just incredibly slow. I mean, you have to wait for plants to grow. Or you could point out that, for now, we still have enough high-grade ores that are just cheaper and faster to mine traditionally. Other great answers are that it takes up huge amounts of land, or simply that it's still a pretty new technology. Any 2 of those, and you've got the final marks. And there you have it. That's the entire 11-mark question, taken apart piece by piece. But, just memorizing answers isn't the point. To really get better, you have to understand what skills the examiner was actually trying to test. So let's do a quick recap.
So just think about what we did. This one question tested 4 totally different skills. You had to be a data detective, pulling conclusions straight from a table. You had to apply your big picture knowledge about things like toxicity and sustainability. You had to be a good storyteller, recalling the steps of a scientific process in the right order. And finally, you had to be a critic, evaluating the pros and cons of a technology.
See, this whole approach, breaking down the question and using the mark scheme as our guide, is genuinely the fastest way to figure out where the marks are hiding. The only question left is, which exam beast do you want to see us deconstruct next? Let me know.